I hope you're all doing well. And last week we were talking about recursive methods, and we also just started talking about classes. So as it is typical, I have some review questions. And these focus primarily on recursive functions, which is also what the homework was from last week. So I have two questions. First of all, what is a recursive function? How is it different from a normal function? What makes it special? And also, if anyone knows, this is also kind of related, what is a base case and why is it important in a recursive
Base is
function?
like the thing where the recursive function stops, and the base case is important because, well, if you don't have a base case, then I guess the recursive function will go forever.
Yeah, so I think you answered the second question first, which is good. But if we go back a little bit, can you define what a recursive function is?
A recursive function is a function that repeats over and over again.
Yeah, that's a good way to think about it. Another way to think about a recursive function, and more of what the definition is that a recursive function is a function that calls itself. And like someone said it in the chat to me, it's kind of like a customizable loop. And that's also a good way to think about it. Essentially, it's a function that as part of the code, it will call itself again and again and again and again, right? And the base case is important because like I think Jeff said, that's how the recursive function ends, right? Because if you're calling yourself over and over again, you have to stop trapped in an infinite loop. So the base case is kind of what stops the recursion, what stops the function from calling itself forever. And so let me go to some code. The homework from last week, I saw some people tried it, which was good, but not that many people submitted. And I know recursive functions is pretty difficult, so I'll spend some time going over it in class now. But please, I hope for these homeworks, I hope you try to find some time during the week to at least attempt the problems. And if you get stuck, again, I want to just repeat this. Feel free to ask me, right? Like, I don't care if you need help to solve the problem. I just want you to have some practice so that it's not just 1 hour a week that you're listening to a lecture and then for the rest of the week you don't do any coding, because just having some practice every day or just every other day, it really goes a long way to really understanding the material. But anyways, the homework from last week was to write a recursive function that would print the Fibonacci sequence up to a certain limit, right? So if I give you 10 as the limit, I want you to print out all the Fibonacci numbers starting at 1, going all the way up to, but not including 10. Right? And so how you might have done this before is with an iterative solution, right? So if we don't think about recursion, what I have here is like an iterative solution, a way with loops. Right? So I define my function and I call this fib iter, right? Because it's an iterative function. It takes in one thing, the limit that I want to go to. Right? And what it does is it creates two variables. I store the previous Fibonacci number and the Fibonacci number that I'm currently at, right? And I say, while the current Fibonacci number is less than the limit, I just print it out and then I calculate the next one. Basically, I take the current Fibonacci number and store that into the previous. And then for the current Fibonacci number, now I have to add up the previous two to get the new one. Right? So this is just a simple while loop that calculates, see this running, I can call fib iter. Here I called it with 20, and you can see it goes 1, 1, 2, 3, 5, 8, 13, which is the Fibonacci sequence. I can change the limit. I can change it to 10, and now it will only go up to 8. I can change it to 100, and it's going to print out a lot more numbers. So this is what you might have been thinking about at first. This is how we've kind of done it before. But with a recursive function, it looks a little bit different. Right? So in this next cell, I have written the recursive function. And I've also commented out where each component is. The code, I will give you the link soon, but this is a new notebook, and I'll also have the stuff later. I'll give you the link. Actually, I guess I can give the link now. So let me just find it. Copy the link, send it to everyone. Okay, so if you go to the link, you should be able to access the code as well, and if you can run it on your computer. But this is what I want you to look at. This is the solution to the homework from last week. Right? So this is, I call this def fib recursion, or fib rec. And it's a little bit different because now it takes in three parameters, right? Before, the iterative solution only took in the limit, right? But the recursive function, if you think about how this is going to work, we're going to call it ourselves again and again and again. So we have to keep track of some information. We have to keep track of the previous, the current, and the limit. So that's exactly the three parameters that I have for my function, right? Inside the function, I have my base case, right? This is when we know that we should stop recursing. We should stop calling ourselves and we're done, right? In this case, we should stop when we've reached the limit, right? If we've reached the limit, we don't need to print out anymore and we're done. So all I say is, if the current is greater than or equal to the limit, I just return and do nothing, right? So this return statement just stops the function. It doesn't allow anything else to happen afterwards, right? So this is how I stop, right? If I haven't reached the limit yet, this is what I do in the else. I will print the Fibonacci number, and then I will call myself, right? This is the recursive step. And you can see the three different parameters. Well, the previous Fibonacci, since I've going to the next one, the previous Fibonacci is now the current one, or the current one is now the previous, right? Because we're moving forward. Now, the current Fibonacci number is now going to be the previous plus the old current, right? The sum of the previous two is the next Fibonacci number. So that's what I pass in here. And then the limit doesn't change. So I'll just pass the same value in. And that's it. That's the entire recursive function, right? And you can see this is actually, it's actually 4 lines of code here. The iterative solution was 5 lines. Both of these you can make a little bit shorter as well. But the idea here is the recursive function is maybe a little bit even easier to write, right? And so that's kind of a reason why you use recursion in some cases. But I also wanted to point out, this line is called the recursive step. And the reason why it's called the recursive step is it's essentially taking a step closer to your base case, right? Because at the end of any recursive function, you want to reach the base case, right? If you never reach the base case, you're never going to end. And that's bad news, right? So this is the recursive step in the sense that you're taking one step closer to the base case. And the reason why this is taking a step closer to the base case is that our base case is when our current reaches the limit. When we call ourselves, the current value is increasing, right? Every time we call ourselves, our current value is getting larger and larger and larger. And so that means we're getting closer and closer to the limit, and we're getting closer and closer to the base case. So in this way, we can guarantee that we're always going to reach the base case, right? Because if we keep calling ourselves, our current value is going to get larger and larger, and at some point it's going to hit the limit, right? Maybe it'll do it in 5 times, maybe it'll do it in 1,000,000 times, right? You don't know how many times you're going to recurse, but you're guaranteed to get closer and closer each time to the end. The last part is not something you had to do, but it was just to point out how before the iterative solution only took in 1 value, and then the recursive function now takes in 3. It's kind of a trick because if you're starting at the first Fibonacci number, your previous and current values are always going to be the same each time. So all I do is I create another function, and this is, I call it fib wrapper because it wraps the recursive function. And this one only takes in the limit and essentially just calls the recursive function with 0, 1 as setting the first 2 values already, and then just passes in the limit. And so you can see this was the iterative solution, and then I can call the recursive solution. I can say the previous Fibonacci number is 0, The current one is 1, so we're starting at the beginning. And then I want to go up to 20. If I run it, it'll print out 1 to 13. I can change the limit to like 50. Prints out some more. I can change the limit to 1,000, right? And it'll print out. I can also use the wrapper function and only use the limit. Right? So I think this is 10,000, and I just print out Fibonacci numbers. So I hope this was a little bit helpful understanding recursive functions. Again, recursive functions is something that is difficult to wrap your head around the first time. It really requires just some practice to look at it, discover the patterns, and then next time, whenever you get a problem, you can think, oh, I know how I would do this recursively. I know what the base case is. I know what the recursive step is, and I can put it all together. Onto the lesson material. Still gonna go through some review because last week I halfway through talking about classes. So I just wanted to recap of what I said last week so we can move on to talking more about classes. And that's gonna be the content for this week. Okay. So the review of classes, I have some code here. This is from last week's notebook. But this was just showing you what a class is in Python, right? So we said a class is kind of like a blueprint, right? In Python, you have objects. You have strings, you have lists, you have dictionaries. These are all objects. A class is like a blueprint for the object. It tells you what it can do, what information does it hold, and all sorts of things like that, right? So in the notebook, we have some example code for classes. The first thing to note was that instead of saying def, like we did for functions, we just say class for creating classes in Python. But you just have class, and then you have the name of your class, and then a colon. Right? In Python, the colon is always signifies a section of code that will follow it, and this is the section of code that follows it. This is the body of the class. Right? Just like how you have function bodies, this is a class body. Inside the class body, you can have different things. You can create some variables. Here we're creating a variable I. You can also create functions. So here we have a function f and we have a function g. Right? They just do different things. If we run this code, it's not going to do anything, right? It's just defining what this class is, what it does. But it doesn't actually create anything. It doesn't actually run anything, right? Just like how when you define a function, right? When we define a function up here, when we ran this cell, it doesn't do anything. You have to call the function for it to do something. Similarly, for a class, you have to create an object of that class for you to actually use any of these methods, right? Or to access any of these variables. So we do that by just this line here. You give it some variable name. This can be anything that you want. And you just say equals, then the name of your class with some parentheses. Right? This is going to be the same for any class that you write. We'll see, maybe you'll have something in the parentheses, but otherwise the structure is the same. Once you have an instance of the class, this is what it's called. So here we stored an instance of the class inside this variable called testme. Once we do that, we can use that instance to access all the methods, to access all the variables. So we can do print testme.f, right? So testme is an instance of my class, and my class has a function f that just returns hello world. So what happens when we say testme.f is this is going to run this function. It returns hello world, and we print it. And so if we run this cell, we should see hello world is printed out. Okay. Accessing fields or data members of a class, that is very similar, but slightly different. You still are going to use your instance of the class. So we're still going to use testme, and we're still going to do this dot, right, this period. But instead of doing like f parentheses, I'm just going to do I, the name of the variable I'm trying to access, and then no parentheses. That's very important to remember. If you're accessing functions, you need parentheses. If you're accessing variables information, you don't need parentheses. Right? But here we do testme.i. So this gets this variable I from here and prints it out. So it's just going to print out 1, 2, 3, 4, 5, 6. And we can see that. We also noted that functions inside of classes are a little bit interesting in that before, when we wrote functions, we created a list of parameters that this function takes in as input, right? If we had 3 input variables, let's look actually at the homework functions I wrote. So this function that when we wrote up here, this is not part of a class, right? We said it takes in 3 parameters, previous, current, limit. If I try to call this function with only 2, so let's just say I try to call fib recursion with only 1, 2, and I don't give it a 3rd number, right? If I run this, it's going to complain. It says, I'm missing 1 required argument, right? This is taking in 3, but I only gave it 2 things, right? So this is how it was previously. But for classes, there's always going to be this parameter. No matter what your function is, it's always going to have 1 parameter. And we typically call it self here. And this is like a reference to the class instance. Right? So it doesn't matter what function you write, you're always going to have self or some variable as your first parameter. And you don't have to pass it in, right? So like here, even though we did def f parentheses self, when we call the function f, we don't pass anything in. It's already passed in automatically. Right? So this self thing is referring to this test me. It's whatever was before the period. So that's a very quick skeleton outline of classes. Where we left off was I just started talking about constructors, class constructors. So I have the slides here. So this is the example code on the slides. And this is talking about class constructors. Okay. What a constructor is just a function. It's a special function, but at the end of the day, it's just a function. Right? It's this thing right here, this thing I'm highlighting. The name of the function is a little bit weird. In Python, your constructor functions are called underscore underscore init underscore underscore. Right? Don't ask me why. That's just the convention. That's just what's set in Python. All your classes, all your constructors are always going to be called the same thing. This underscore underscore init underscore underscore. Right? Then the function takes in some number of parameters. Right? So this first thing, my silly object, this is the self. Right? You can call it whatever you want. Here we call it my silly object. Typically, you call it self. You could call it ASDF. No one's going to care. As long as you're consistent, it doesn't matter. But then this constructor takes in 2 more things, a name and an age, right? Because if we look at this, we're creating a class that represents a person. So it makes sense that when you're creating a person instance, right, a specific person, that person is going to have a name and an age. So you want to create a constructor that takes in these things and creates a person with those attributes, right? And if you see what we do with this, we say my silly object dot name equals name, right? So this is a little bit confusing because name is everywhere. But to clarify this a little bit, oops. Here, this name is whatever you passed in, right? This and up here, they're the same thing, right? On the left-hand side, this is a little bit different. This is storing it inside of an instance variable, right? So the variable, the name of the variable is going to be called the same thing, name. But you show that it's different from this one, is that it has this my silly object dot in front of it. Right? So saying this name variable belongs to this object, right? It's the object's name, right? It's no longer the parameter that you passed in. It's the name that belongs to the object. It's the name that belongs to the person, right? We do the same thing with mySillyObject.age equals age, whatever we pass in, right? Then we have just a normal function, not the constructor. Here, just to show that you can call the first parameter anything you want, here we call the first parameter ABC, right? And then we can use this ABC parameter to access our name variable. So when we do abc.name inside of this function, it's going to access the same variable, right? Even though we say ABC here and mySillyObject here, they access the same thing, right? I have this code pasted in here, I believe. So I have two versions. This is the version that appears on the slides. I also have a version where I renamed everything to self, just because I think self makes a little bit more sense when we're being consistent. So you can run, like you can execute either one. It doesn't matter. They work the same way. But so if you run the self, it creates the class, but again, doesn't do anything yet, right? What we do next is we create an instance of the class. We create a real person. Right? Up here, we just define the blueprint, but now we're going to use the blueprint to create a specific person. Right? So here we say P1 equals person, and then in parentheses, we have our name and our age. Right? So you see here, this is our constructor at work. Right? In our constructor, we said self, because it's always self, and then name, age. And then when we're creating instances now, we pass in a name and an age. Right? And these things are going to be stored in our instance variables, which we can access later on. Right? So if we do P1 equals person, John 36, this line is going to create a person object. This person object is going to have a name John and an age 36. When we call p1.myfunc, it's calling this function right here. Right? This self parameter is automatically passed in. It's this p1 thing. Right? And what this function does is it prints out, hello, my name is, and then plus self.name. Self.name is what was where this John was stored. So it's going to print out, hello, my name is John. You're going to run this cell. You can say, hello, my name is John. I can change this. I can say Jack. And if I run it, it's going to say, hello, my name is Jack. Right? I can change this to whatever I want. And it will use that instead. I guess just to clarify variables really quick. If I want to change this, right? I want to ask you guys just a little pop quiz at first. So if I change this up here in my function parameter list, if instead of name, I feel lazy and I don't want to type out name, I just say n, right? N right here. This code is going to break. I have to change some things to n now. I have to change names to n because it used to be name. Now I just turned it to n. The question is, which one do I have to change? Do I have to change this name to n? Do I have to change this name to n? Or do I have to change both of them to n? Right. So is it on the left, the right, or both? Okay, so I have one answer for both. Does anyone have another guess? How about Martin? Do you have a guess? Even if you're not sure, which one do you think I'm going to have to change? Or do you think I'm going to have to change both of these to n? Okay, so both is, it's correct, but you don't have to change both actually. You can, you're gonna have to do some more work later. But the only thing that you have to change is what's showing up on the right? Because before, when this was named, this and this thing, these two are the same value. right? This is what it would, this is whatever was passed in. This was the John, and then this is also the John. So if we change this, if we change the name of the variable to n, we're gonna have to change this to n. Right? Oops. But if you remember from before, this variable and this variable, this was different. They're two separate things. So you don't actually have to change what's on the left, right? If I run this code and I run the calling again, you can see everything still works. It's fine. You can change this. If you change this to n, then it's going to break the code. Right? I get this red line if I try to run it. Because if I change this one, this is linked to this one, this self.name, right? So if I change self.name to self.n, then I have to change this self.name to self.n, right? So to recap, this name and this name, they are linked together, right? If you change one, you have to change the other, right? If this one changes, then if the value of this changes, then the value of this changes, right? However, this self.name is, I mean, it's related because we're storing it. We're storing the value name into self.name, but otherwise has no relevance, right? Doesn't matter what you call this. You can call this Bob. You can call this like ASDF. Doesn't matter. Right? If you call this ASDF, you have to call this ASDF, but you don't have to change self.name. This is separate. However, this self.name and this self.name, they're linked together. Right? So this here at the bottom and here, this self.name, they're linked together. This ASDF and this ASDF, they're linked together. Right? Not all four, it's just the two and the two are linked together. Right? And so you can just have some fun playing around with it. The way to keep this in from getting mixed together is that the name here, we used to have name, and this is name. This gets its value from whatever was passed in, right? This is just a function. When you call a function, you pass in some variables inside, pass in some values. When you pass in something to this function, it stores it in this variable called name. And then whenever you say name afterwards, it gets the same value from there. However, self.name is a little bit different. Each different person is going to have a different self.name, right? This self.name belongs to a specific person, right? And so we can see this by actually, we can create multiple people, right? That's the power of classes. Classes are a blueprint. You can use a blueprint as many times as you want. So here we created a person one and called p1.myphone. I can create a person two and say person, and I can give it a different name, JKL, and then I can give it a different age, let's say 12. And then if I call p2.myphone, it's gonna print out something else, right? When I create this second person, right, it doesn't affect the previous one, right? This p1 has a self.name, which is set to ASDF. The second, when I create another person, it creates another copy, right? This p2 has its own self.name, right? It has a different one, right? This is how you create a single class, which you can use multiple times, and they all have different values, right? So you're going to see this pattern quite a lot. Typically, you're going to have a constructor. It takes in some number of variables, some number of values, and then stores it into self.whatever variables. Right? It stores it in there because then later on in other functions, you can access it. Right? That's why you do it. And when you do these self.whatever variables, each different person, each different instance of the class has its own copy. Right? They don't share anything, they're separate. Here, I think I have another example. It's very similar, so it's not really that much more interesting. But a thing to note is that when we define this constructor, here we define the constructor, it takes in a name and an age. Once we do this, we can no longer just do like P3 equals person. If we do this, it's going to complain. It's going to crash. It says a init is missing 2 required positional arguments, name and age, right? Because, like I said, this is the thing that you should keep in your mind. The one thing that you should take away from all this, the constructor is just a function. Right? It's a special function. If we say definite and we define it with 2 parameters, name and age, whenever we create a person now, we have to pass those in, right? We said the function takes in these things. If we don't give it them, it's gonna be really mad at us, right? So now whenever we create a person, we have to pass in a name and age, right? If we wanted to make it so that we don't have to pass in these, it's just a function. You can create default values, right? I can say age is by default 10. And then now I can do P3 equals person, and then I only have to give it a name, right? Joe. And now this is going to be fine. I can also give name a default value if I want. And then at that point, then I can do person with nothing inside. Right? But okay, to recap, a constructor is this special function that's called underscore underscore init underscore underscore, right? There's 2 underscores here on either side. This is a special function that is called whenever you create an instance of the function. Hence, that's why it's called a constructor. It's called whenever you create an object. It constructs the object for you. If you define the constructor and you give it some parameters, whenever you're creating an instance of the class, you have to pass those in now. Right? It's just a function, has the same rules as anyone else. Also, the things to take away is just this self dot thing, self dot name versus no self dot name. Yeah. So I want to take a moment. This I know was a lot of content, so I hope you take the link that was in the chat and open up the notebook and just run these things yourself. You can try to change some things around, see if it crashes, see if it still works. Play around with the values. As homework, just as a sneak peek, I'm going to have you write some classes. They don't have to do anything special. Like I'm going to have you write a class that has some functions. The functions don't really have to do anything special. They can just be print statements. But I'm just going to have you create your own classes for the homework. But I'll give more information when we get to that point. But for now, does anyone have any questions about what I said? About what a class is, what is the constructor, and this whole self thing? Okay. If you have any questions that come up as I talk, feel free to speak up or put something in the chat to me. You can do it publicly or privately. But for now, I'm going to move on to some more special things that you can do with classes. Right? So before we just saw some basic examples of classes, but there's actually a lot more you can do. The first thing that I'm going to talk about is what's called nested or inner classes. And you can guess from the name of this, it's going to be classes that are contained within other classes. Right? And in computer science terms, this is what's called encapsulation. It's like when elements are enclosed of other elements. And this is done to like sometimes hide information. It's also done to organize your code. Right? And we'll talk a little bit about that soon. Really quickly, here's just some really dummy code for creating nested classes. We just define an outer class. So we say class and then the name of it. And then inside the body, inside the colon, we create another class, right? Class the inner. These classes don't have any code inside of it. We just say pass, which means There's nothing to see here, move on, right? It's just like placeholder values. What's important to note here is that, first of all, this class is contained within the outer class. And what that means is it's a distinct entity. So this is distinct. It's separate from the outer class, right? They're related to each other, but they're still separate. So the inner class doesn't have any like special access to the outer class's variables or methods. It will access it just like anything else. Right? It doesn't have any special privileges, is what this slide is saying. To get like a more useful example of nested classes, we have one here. This is also showing up in the notebook. Oops. So under the section nested classes, you'll find the code that was on the slides. So what we're doing is we're first defining an outer class. The outer class is called human. And then inside this outer class, we define an inner one, class head. Right? If we run the code, this just defines the class. And then the next cell is like using the class. Right? So if we look at this, examine this quickly. This head, this is a distinct class. It's just like any other class that we've talked about. Everything applies. You can create constructors. You can have self.name variables. Everything that we talked about applies to this head class, right? It's just a class. What's special here is that it belongs inside of the outer class human. And because of that, we can do stuff like this. Inside the constructor, the underscore init underscore function for human, we say self.name equals Guido, and self.head equals self.capital H head, right? So the names is a little bit confusing, but if you notice, this is lowercase, this is uppercase. So if you're ever confused, typical Python naming convention is that classes are capitalized, right? The first letter is capitalized. Variables, typically they're lowercase. So what's on the left is a variable. This is the name of a variable. What's on the right is a class, self.head, right? So this self.head is saying, okay, inside myself, right? That's what the self variable is saying. Inside myself, I want to create a head class, right? So we say self.head because head is within itself, right? Because it's nested. It's an inner class. So this self.head is creating an instance of the head class, right? Just like how we did before, this is creating an instance of the class. It's calling the constructor. Right? What happens then is this instance is then stored inside of this variable. Right? This variable becomes a label that we can use to access the instance. So what we can do now is first we do Guido equals human. Right? So we create a human object. Right? When we create the human object, it stores this string inside of this name variable, and then it creates a head object and stores it inside of this other variable. We can do print guido.name, which accesses this object, this variable. We can also do guido.head.talk, right? So if we break this up into its parts, guido.head, this is accessing the self.head variable. Once we have access to this head object, then we call the .talk method on the head object. Right? If we look at the class head, it has this talk function. Right? And then the talk function just returns the string talking. So if we print it out, it's just going to print out talking. So again, this by itself is not very exciting. It's not very useful, but it's just an example of doing inner classes. So we looked at the code, and it's not that exciting. So the question is, why does this matter? Why is this in Python? Why would we use this, right? And it's kind of just for organization's sake and for clarity's sake, right? So in that example that we saw, the outer class was human and the inner class was head, right? that is a relationship that kind of makes sense, right? Because one part of a human is a head. Like the head and the human are related to each other. The head is inside of the human. It's a part of it, right? So it makes sense to have the head class inside of the human class, right? It just makes sense organizationally to do that. It kind of keeps these things together. So you don't have one and then not the other. It's a little bit neater. And so that's what this slide is talking about. When we're importing packages, importing other libraries, it's just a lot cleaner if things are grouped together like this. Again, there's this concept in encapsulation. And so encapsulation is sometimes it's important to hide things from the outside world, right? How this inner class happens is that if you don't tell anyone that you have an inner class, no one's going to know about it, right? Like, unless you tell someone it exists, they don't know. How are they supposed to know, right? It kind of hides it from the world. It hides it from people who might want to mess with it. Right? Maybe you're a hacker and you want to change these variables. By encapsulating it, it kind of keeps it separated a little bit and keeps it a little bit more hidden. Finally, last point is also just still about organization. It's just a little bit more readable sometimes. If you have two classes that are very closely related to each other, you might just want to make them inner classes, right? And the last point on the slide is saying, we said all these advantages, but at the end of the day, there's no reason to use inner classes or not to use them. Like anything you can do with inner classes, you can also do without them, right? They don't add any power. They don't allow you to do anything extra. It's just a nice feature that you might find useful. Right? This is different from the next thing we're going to talk about. So that was actually the end of nested classes. Again, if you want to look at some stuff, it's just the code here. You can create your own nested classes as well. So examples would be like, maybe you have an outer class that represents a library class. And inside you would have a book class, right? Because you can imagine that a library is going to have a lot of books and they're probably going to be very closely related to each other. So you might as well just nest it inside of it, the outer class. That's all about I'm going to say for nested classes. At the end of the day, you don't need to use it. It's just good for when you're writing large projects and writing like large scale Python code. It's a good practice to use. But when you're just writing like little bits of code, just little scripts that you are doing for fun, no one's going to yell at you if you don't use the inner class or if you use the inner class. It's just a design choice. Right? The next thing though, inheritance, is very useful. And you're going to use this a lot and you're going to see it a lot. So inheritance, if we don't talk about coding, for example, for now. So when we talk about inheritance in like biology or genetics, it's like you have a parent and you have a child and you're passing some things along, right? Maybe you inherit certain traits from your parents, right? Maybe your parents are really tall and then the kid is also very tall. It's passed down. In coding, inheritance means the same thing. Right? What inheritance does is it creates a sort of hierarchy. Now you have parent classes and you have child classes. Right? And you can have grandchildren class. You can have grandparent classes. You can nest this as much as you want. Right? And what inheritance does is it allows you to not start from scratch. Right? You can start off by taking another class and building on top of it. Right? Just like in humans, when you start off, you don't start from scratch necessarily. You take a lot of things from your parents. So in programming, when you create inheritance classes that inherit from other classes, you already get everything that the parent has, and then you can add more functionality to it. Specifically, it inherits all attributes and methods of the parent class. So any functions that the parent class defines, the child class is also going to have access to. You don't have to define it again. You just automatically have access to it. Same thing with attributes or fields or variables. So for example, if we have this class human, if we create a child class, something that inherits from human, it's going to have, it's going to have these self.name, self.head variables. You don't have to say it again. It just automatically gets access to them. Right? And so you can imagine why this is going to be very useful moving on. Everyone's lazy. We don't want to start from scratch every time. We want to take advantage of something other people have already written. Right? Just again, making sure the terminology is clear. We're going to say parent class, which is the class that is being inherited from. Sometimes you might also hear this as the base class. The child class is the class that inherits from another class, right? Again, if it's not clear, just think about in humans, in genetics and biology. The parent is where the information is coming from. The child is the one that receives it, right? Same thing in programming. The parent is being inherited from. The child class is what inherits to, essentially. Sometimes another term for it is derived class. So you have parent-child, base-derived. So I don't want to scare you, but this is a chunk of code that implements this parent-child inheritance idea. So as always, this code is on the Collab notebook, so you can run it and play around with it. But I just want to show you how it works from a code standpoint. Right? How do we create classes that inherit from another one? And it's actually very simple. Right? This parent class is, as you can guess, the base class. This is the starting point. It creates all these things. It has a self variable, it has a constructor, has these methods, right? And then what's interesting is we create a child class, right? And to do inheritance, it looks a little bit different, right? If you notice, how is this different from before? Well, before, when we defined the parent, after the name of the class, we just had the colon, right? We were just done. When you're inheriting from somewhere else, you have something between the name of the class and the colon. You have this parentheses. It's kind of like a function parameter list. This is saying, here are all the classes that I'm inheriting from. And so that's a sneak peek. You can inherit from like as many classes as you want. You don't have to have only one parent. You can have 5 parents. You can have 50. Probably never going to do that, but you can. So here, for this child class to inherit all the functions, all the variables that the parent has, all we do is say parentheses, and then the name of the class that we're inheriting from. So in this case, we just say parent with a capital P. Then we define some extra methods. We define a constructor method, and we define this child method. Right? And the next slide is basically saying play around with it. So I have it under this inheritance section. The first cell is just defining the class, the code that we saw on the slides. The next thing was to play around with it by creating a parent object and creating a child object. So at this point, I want you guys to help me out with a little bit. Just as a review, how do I create a parent object? Right? How do I create an instance of the parent class and then store it inside of a variable? Right? So can anyone tell me what I want to type here to create an instance of the parent class? How about, I'm going to call on someone. How about Chloe? Can you help me with creating an instance of the parent class? As a hint, this is the constructor. And this constructor doesn't take in anything special, right? It has the self, which all constructors, all functions are going to have, but it doesn't take in any other parameters. So what does that tell us on how to create a parent object?
I don't really know.
Okay, that's fine. Does anyone else want to help Chloe out or have an idea of what we want to do? Okay. I'm gonna scroll up to a little bit. So in this section called classes review, we have an example of how to do this for a different class, right? At the beginning, we define this class. It's called my class, right? And then in this cell here of the comment, here we create an instance of our class, right? All we do is on the left hand, we just give some name for a variable. Can be whatever we want. It's just the name. Then we do equal sign because we're assigning something to it. And on the right-hand side, this is where we're creating the instance, right? All we do is the name of the class, and then parentheses, and then any parameters that we might need to pass in, right? So in this case, when we're talking about the parent class, if we look at the constructor, it doesn't take in anything special, right? It has the self, which everything has, but it doesn't take anything else. So that means we don't need anything inside the parentheses, right? So to go through this, if I say parent, the name of the class, and then just add some parentheses, what this is going to do, this code that I've written, it creates an instance of the parent class. It creates an object, a parent object. Right? However, that's not useful by itself. We want to take this and store it into a variable so we can access it over and over again and later on in our code. So I can just say like PRT equals parent, parentheses. If we run this, it's actually going to print something out because if we look at the constructor, it prints out this thing, calling parent constructor. Right? So after I said this, how about Chloe? Still, instead of creating an instance of the parent class, I want to create an instance of the child class. So as a hint, it's going to be very similar to what we just wrote. Again, if we look at the constructor, it doesn't take in anything other than just the self. So what does that tell us? How do I create an instance of the child class?
Just write a function in the child class.
So I want to create an instance of the child class. So in this cell, I created an instance of the parent class, right? I just said PRT, the name of the variable, equals parent, parentheses. So now I want to do the same thing, but just with the child class. So how would I do that?
ASDF equals child, parentheses.
Yep, that's exactly right. It's basically the exact same thing. So here we said ASDF, but this is just the name that we're assigning it. Can be anything. So to make things a little bit more clear, I'm going to say like CLD. Or yeah, CLD for child. So we have PRT for parent, CLD for child. If I run this, you can probably guess, if we look at the constructor, it's going to print out this line, calling child constructor. And so it's actually interesting. This is actually overriding that behavior from before. But before I go on to talk a lot about that, I just want to talk about all these functions that we defined, right? So in the parent class, if we looked at the code, we see that beyond the constructor function, we have these three other functions: this parent method, set age, get age, right? So these two are called setters and getters typically. They're very common. They basically just, one is to set the value of a variable, and the other is to get the value of a variable. Right? And so we can call these things through this name that we gave our parent object instance. So up here, we created an instance of the parent class. We stored it inside of this variable called PRT. And now we're going to use this to call all these methods. Right? So I can say PRT.getAge. Right? And if I do this, it is going to say parent attribute 40. I can do PRT.setAge, and then I have to give it the value. So I'm going to set the age now to 30. Right? And then I'm going to do, after I set it to 30, I'm going to get it again, PRT.getAge. If I run this, you can see that now when I do parent.getAge, it prints out 30, right? Because we've set it to a different variable value. However, what's interesting and what's good about inheritance, right? I said that when you create inheritance, the child class automatically gets access to all of the functions in the parent class. So if we look at the child class, inside the child class, we don't have getAge, setAge, all these things, but we get access to them automatically because here in this parentheses, we inherit from parent, right? So because of this, I can take the child instance, this CLD, and I can getAge and setAge, right? So I can do cld.getAge, and it will get the same age 30. Now that doesn't really make sense because a child is probably not going to be age 30. So I can do child.setAge, maybe 12. And then if I do cld.getAge, it's going to print out 12, right? And so this is interesting because we only wrote this function, setAge, getAge, up here in the parent class. We only wrote it once. However, both the parent class and the child class have access to it, right? We wrote it once, and now it's available in multiple places, right? And this is really good, right? Because if we think back to writing about functions, writing about loops and all these classes, at the end of the day, it's just because we're lazy. We don't want to write code repeatedly. Like we have loops because we don't want to write the same line of code 10 times. We want to write a single loop that will do it 10 times for us. We write a function because instead of copy pasting a chunk of code in different places, we just write it once and then call it wherever we need it. Here it's the same idea. We write the function once, right? We write it once in parent class. And then if we want something else to have these functions, all we do is we inherit parent. And then all of a sudden we have access to these, right? And if you think back to one of the fundamental concepts to programming is the idea of not repeating yourself. And this is not only just because we're lazy, it's also because we're smart. Because what happens if this function setAge, we find out, oh, we made a mistake, right? There's a bug in this code. Then what do we have to do? We only have to fix it this one place. And all of a sudden, everything that inherits from parent has their setAge function also fixed, right? We only have to change it one place, and then it changes it everywhere, right? And so this is kind of why inheritance is useful and why this whole object-oriented programming is so popular and everywhere. So I talked a lot for today, and we're at the end of class. So I want to just recap again everything we talked about. We were talking about classes, right? We started with just the fundamentals. A class contains functions and they contain variables. Right? Then we went on a little bit deeper. We said a specific function that a class has is called the constructor function. And this is a special function because it's used to create an instance of the class. Right? We can create a constructor function that takes in certain values and then store it inside of our class later. Afterwards, we talked about nested classes, which is just a way of organizing your code. It doesn't do anything really special. It doesn't add any power. It just makes your code a little bit more readable and nicer. Finally, we talked about inheritance, where this is actually adding power to our classes. It allows us to not start out from scratch. When we're creating our child class, you can imagine the child class has a lot of similarities to the parent class, right? Because they're both probably about humans, they both deal with ages. So when we're writing the child class, we don't want to write everything again. We're lazy, so we inherit from parent. And because of that, we have access to all the things that the parent class has. So next week, we're gonna go on. I think there's a little bit more I have to cover about classes, and then we can move on to some maybe more interesting topics. But the last thing before we go is the homework for this week. So I will post this on Google Classroom as well. but the homework for today, this week, is just an exercise on writing classes. So the slide, and I'll post this, is saying write a class with 3 attributes. So these are variables and also 3 methods, right? So this can be anything you want. An example on the slides is vehicle. And then after you create that class, you're going to create a child class, which derives from it. So inherits from the upper class. And this, we didn't get to explaining what this is exactly, but I just want you to, in your child class, create a couple more methods, right? So the example on the side is maybe the first class is a vehicle class, and then your child class is a truck class, right? So if we talk about this example, a vehicle class might want to have an attribute like color, an attribute like top speed, an attribute like number of wheels, right? The truck class might add some more attributes, might have an attribute like, is this a pickup truck, right? Something like that. It might have extra methods like unload the back or drive around, right? And these functions, they don't actually have to do anything. You can just have it print out a line or something, but just practice writing classes, creating classes that inherit from something else, attributes, methods. Just so I want you to spend a little bit of time and submit this on Google Classroom, as always. So that's it for this week. If you have any questions, feel free to stick around. Otherwise, I hope you have a great week, and I'll see you next Wednesday.
Thank you. Bye.
No problem.